Welcome to qnawire.
Okay, so let's draw a diagram. We have our Cartesian axis here. And going straight to the left, we're going to say this is the displacement vector to the west. And then going straight down to the southwest would be our displacement vector southwest. From the origin here, we can say that our resultant vector would then be equal to this vector here. We're going to say that this is displacement resultant. Adding the vectors, the resultant displacement would be equal to the west displacement plus the displacement in the southwest direction. So let's actually specify. This would be west plus the southwest displacement. And we can say that the westward displacement here would be, so drx, in a sense, the x component of this displacement would be 225 plus 78 cosine of 45 degrees, giving us 280.2 kilometers. For the southern displacement, so it would be the resultant displacement in the y direction. This would be 78 sine of 45 degrees, giving us 55.2 kilometers. So essentially, this can be, the resultant displacement can be represented by vector notation. So we can say 280. Rather, if we can consider west to be negative and south to be negative, it will actually be negative 280.2 I hat minus 55.2 j hat. The units, of course, would be kilometers. And then if we wanted to find the magnitude, we could say that the magnitude would be equal to negative 280.2 squared plus negative 55.2 squared, all to the 1/2 power. And this is going to equal 286 kilometers. So this would be the magnitude. This would be the components of the resultant displacement. And then finally, if we want to find the direction, theta, this would simply be arctan of the resultant displacement in the y direction divided by the resultant displacement in the x direction. And this is giving us arctan of 55.2 divided by 280.2. The negative signs, of course, cancel out. And theta is going to be equal to 11 degrees. And we can say the direction here would be south of west. That is the end of the solution. Thank you for watching.